Hello everyone, my name is Francis Joe. I'm from Kawada Technologies, Tokyo, Japan. Before I get started, I just want to thank IIT Mumbai and Techfest for organizing this wonderful event. We at Kawada are really honored to be part of this event. I think it's a great initiative during these unfortunate times. Organizing these online exhibitions gives most of the people who are staying at home to get an insight into the latest technologies. So today I'll briefly introduce the Kawada group of companies, and then I'll move on to the main topic of the day, that's Kawada Robotics. So let's get started. So KTI stands for Kawada Technologies Incorporated, which is a holding company of the Kawada group of companies. So Kawada Group is basically a conglomerate. We are primarily into construction and civil services. We are actually one of the very few companies in the world that can undertake the whole design, fabrication, erection, and maintenance of not only steel, but also concrete and hybrid structures. So this is our main primary business. But if you look at the other business sectors, we also have the IT services, where we have our own 3D CAD software. And this 3D CAD software is basically used primarily for bridge construction projects and is like a de facto standard currently in Japan. And then we have the aviation sector, where we have helicopters and aircrafts. These helicopters are actually used in disaster-stricken areas. It's used for sending relief packages to rescue people, for news coverages, things like that. And the aircrafts are primarily used for tourism. Then we also have green technologies. So as you can see on the picture on the left side below, is actually a greening system. It's a rooftop greening system which we have set up in a museum in the city of 𝗏𝗏𝗏𝗀. So it's basically 35,000 square feet of space on top. So this greening system is called 𝗏𝗏𝗏𝗀. It's a self-sustainable greening system which actually maximizes vegetation and crop growth by drastically reducing maintenance and water consumption. And of course, we have robotics. That's where we are today, and I'll brief you on that in the coming slides. So just as I mentioned, these are the main business activities of the Kawada Group. And this is the corporate overview. Our president is Mr. Tadahiro Kawada. He's a great visionary, and he's always coming up with new ideas and new innovative technologies. And our company was actually founded in 1922, so it's almost a 100-year-old company. And these are some of the other stats. So these are the group of companies of Kawada. And as you can see, the Kawada Industries is the core operating company of the group. So in 1922, a gentleman by the name 𝗡𝗘𝗫 Kawada started this very small steel forge in a town called 𝗏𝗏𝗏𝗏. And over a span of 100 years, Kawada has grown into this multifaceted organization, which we're really proud of. And Kawada is known for its quality work, customer service, and innovation. So moving ahead. So this is the global footprint. We have world-class structures in different parts of the world. And mind you, we'll be striking off India soon. We've just started a few pilot projects of the greening technology in India. We should be launching in India soon. So for world-class projects, what's required is world-class structures, world-class facilities. And so these are our state-of-the-art manufacturing facilities. So the first one is in 𝗏𝗏𝗏𝗏, which was established in 1922, which has a production capacity of 2,500 tons per month. The second one is in Tochigi, which is the largest of the facilities, which was established in 1958 and has a capacity of 8,500 tons per month. And the last one, which is in Shikoku, this one has a capacity of 3,500 tons. So as you can see, these are some of the world's best facilities, and our facilities are graded at the highest quality in Japan. So I just want to touch on one of the projects, which has been a remarkable project in the history of Kawada. So this bridge is called the Akashi-Kaikyo Bridge, which actually connects two islands in Japan. And as you can see, the length of the bridge is almost 4 kilometers long. And Kawada holds the Guinness World Record for the longest central span for any suspension bridge. And the span is almost 2 kilometers long, which was actually a remarkable feat. if you go on to Google and YouTube, you can see the construction videos and pictures. It was unbelievable during that time. So just to put into comparison, since you guys are in Bombay, you can, you guys have the 𝗏𝗏𝗏𝗏 sea link, right? And which is actually a cable stayed bridge. This one is a suspension bridge. So the cable stayed bridge in 𝗏𝗏𝗏𝗏 has a central span of just 250 meters. This one actually has a central span of almost 2 kilometers. So that's how big this bridge is. So moving on to Kawada Robotics, as you can see, we've been in the business for over 20 years. So I'll just briefly touch on the history of Kawada Robotics. So as you can see, the Kawada Robotics business roots back to the early 1990s. This was when Kawada was actually manufacturing helicopters, and we had ambition to actually set up an autonomous flight control system for a real-size helicopter. And so we acquired this helicopter from another aircraft company, and we modified it into a multi-purpose, high-performance unmanned helicopter, and we called it the 𝗩𝗏𝗏𝗃 300. So as you can see from the pictures, these are this was actually a real-size helicopter which had features like a joystick control. You know, you could actually control it with a joystick, auto navigate, auto hover. So, in the 1990s, we had the bubble economy, and so we decided to put the 𝗩𝗏𝗏𝗃 project on pause mode. So during this time, during this time, the engineers who were actually in the 𝗏𝗏𝗏𝗏 division decided that they should just experiment by taking on various outsourcing businesses in engineering and R&D. So they decided to experiment with different types of clients, right? In the automotive sector, aerospace, gaming, Japanese Defense Academy, etc. And they decided to just manufacture different types of mechatronic devices. So as you can see in the pictures, these are some of the unique devices which were actually manufactured by the team which actually left the 𝗩𝗏𝗏𝗃. On the left side is actually a motion data logger for penguins, where we can track the penguin movement. And then we have this anti-vibration device for wheelchairs. You put in the vehicle, it doesn't move. And vibration for joy chairs. You know, today some of these video games have that, right? Where when you're in the game, the chair moves and it's like a 3D effect. So these were some of the projects which they took on. And so Kawada was just experimenting and launching these. So during the mid-1990s, so this was when the first humanoid robot was born. So our president actually got a call from an automotive customer. He said, there is this professor in the University of Tokyo who actually wants us to create a robot which actually looks like a human. And so it was actually a very prestigious thing, because we got a call from the University of Tokyo, which is actually one of the possibly the most prestigious university in Japan. It's like the Harvard of Japan. So we decided to take on that project. And that's when it led to the first development, which is called the 𝗏6. And then for the following year, we came up with the 𝗏7, and Kawada developed their own robot called the 𝗏𝗏𝗏𝗏. And these were some of the functions which these robots had. It had basic walking functions such as online dynamic balance, compensation, online walking trajectory generation, etc. And manipulative functions such as arm motion planning, 3D vision-based interactive planning, and human interactive functions such as it could identify humans, it could track facial recognition, voice recognition, etc. So this was actually a very impressive feat for the time period. And Kawada continued to supply these robots to the University of Tokyo with the modification and improvements as per request from their professors and students. So moving ahead, come early 2000, we were actually invited. So METI and NEDO is, as you can see, is the Ministry of Economy, Trade and Industry. They actually invited Kawada for the first humanoid robots project. So they were pretty impressed with Kawada's technology and the time frame for the robot production. They said they invited us to lead the project. And so this led to the development of the HRP2, which is actually P is for prototype. And within a year, the HRP2P was developed, which is actually a very unique design. It was, in Japan, they used to say, this actually is an anime kind of design. And for this time period, so this was one of the only robots which could actually stand up after it falls down on its back or on the front. This was something which the Asimo of Honda could not do during that time period. So moving on, 2005, with the success of the 𝗩𝗏𝗄2, we decided to make a more rugged and more sturdy robot. So this was the 𝗩𝗏𝗄3P. So this robot was actually dust-proof, waterproof. It had the ability to walk on slippery surfaces and even use the power tool. So, and with the technology we actually made more advances into the 𝗩𝗏𝗄, and we made the one which was actually able to work in a practical environment. So this one was the most advanced one of the 𝗩𝗏𝗄3, which actually had more dust and splash-proof functions for even the joint axis and the electric devices, and improved cooling systems, and also prolonged operation times. So the previous one had a 60-minute operation time. This one had a 120-minute operation time. So moving ahead. So come 2005, there was this World Expo in Aichi, Japan, and it was a very unique project. It was called the Biped Dinosaur Projects. So as you can see from the pictures, so these are two dinosaurs which was actually at display at the Aichi exhibition, and Kawada operated the robots to do 8 demonstrations every day of the expo. And the T-Rex was actually 3.5 meters long and could walk on 2 legs at a speed of 1 kilometer per hour. So both these dinosaurs were very advanced in the architecture during that time period. So this was the time when actually Kawada was thinking ahead, and we realized that it was necessary to have a sustainable business model using the robotics know-how, and that's when we actually started developing our current project, which I will detail you out in the coming slides. So Kawada continued to support the Japanese National Laboratory's efforts with the biped humanoid robots, and during this time, the AIST, which was actually the National Institute for Advanced Industrial Science and Technology, in collaboration with Kawada, started to produce very interesting projects. So this one was called the 𝗩𝗏𝗄4C, which is actually a very popular project. If you look at the robot itself, which was actually designed to look like an average Japanese woman in terms of structure. And this was one of the only robots which could actually dance. So there's actually a video on YouTube. If you go onto YouTube, you can see the video. As you can see, the person in the center is actually a robot. So it could move like a human. You know, it had 30 body motors and 8 dedicated facial expressions. It could recognize speech. It could actually sing songs. So it was very advanced during that time and very, very realistic. And it was actually labeled super realistic during that time period. And there was also the 𝗩𝗏𝗄5P, which was actually developed with the AIST, which was actually used for construction. You can check it out, check out the videos on YouTube. It's a very unique robot which can actually lift plywood sheets of 10 kilos and can actually go and put it on the wall and drill it. So there are very interesting videos on YouTube. So moving ahead, year 2010 was when we developed the 𝗩𝗏𝗄4. This was actually developed keeping in mind the concept of working with human beings actually. So slim athlete concept pursuing affinity with humans. So as you can see, it's a very, very slim robot. We reduced the weight of the robot. And the most unique feature was the degree of arms, the degree of movement of the arms in this robot, which is actually increased. So the degree in the arms is actually very critical for object handling. As you can see, this robot was able to pick up a bottle and pick up a PET bottle, pour the liquid into a glass. So the concept was safer collaboration with humans and lighter, slimmer, and very compact, as you can see from the pictures. So moving ahead, in conjunction with biped robots, we were actually also developing the 𝗍𝗏, which was actually a very unique robot. This was one of the first robots which could actually think for itself. It can actually put together different tasks and even make assumptions on how to complete them. It could also use the internet, just like today, how we use Google and like Siri and Alexa, you know, they can, if they are not sure of a particular answer, they can search the internet. This could do it. During that time period, it was a big thing, you know, talking about 2009. So this actually developed to our current project called the NEXTAGE, which is actually the next generation dual arm industrial robot. So this is what the robot looks like, and I'll show you a quick video on all the working functions of this robot.
NEXTAGE consists of 15 axis joints, 2 in the neck, 1 in the waist, and 6 in each arm. The 15 axis joints are capable of delicate work, enabling NEXTAGE to operate in the same workspace as humans. With regard to safety, all 15 axes consist of low-power motors of 80 watts or less. Out of consideration for people working next to NEXTAGE, it has been designed so that the elbows do not protrude even when both arms are working. NEXTAGE has 2 cameras in the head and 1 camera in each arm. The 2 cameras in the head recognize markers placed on the workspace, jig, etc., enabling NEXTAGE to recognize the surroundings, location, position of peripheral equipment, etc. in 3D. In addition, using the hand cameras for 2D image recognition at close range improves performance. Combining hands and peripherals makes it possible to perform a wide variety of work. NEXTAGE can change hands automatically, enabling it to perform multiple processes. The base has casters that make it simple to move and position NEXTAGE depending on the floor layout. Combining NEXTAGE with the AGV unit enables it to move around autonomously. NEXTAGE achieves flexible and low-cost automation that has been unthinkable with devices so far, enabling it to be used in a variety of fields. In the medical field, NEXTAGE can do everything, from dispensing drug solutions and smearing Petri dishes to transporting samples. In the industrial field, NEXTAGE can do everything, from assembling components to fastening screws. By changing hands, it can even be placed on other work lines. Even processes as complicated as this don't require any special programming. The mouse can be used to teach NEXTAGE with ease. Work processes can also be managed with ease by using workflows. Featuring an all-in-one package of functions, including image processing, and able to perform the multiple processes associated with working and moving in the same environment as humans, NEXTAGE fulfills applications that have never before been possible. NEXTAGE also prevents human error and liberates people from menial repetitive labor. It takes robots from being merely equipment to being partners. The next generation industrial robot NEXTAGE is the next stage in robot evolution.
Touch on some of the differences of traditional robots and the NEXTAGE. As you can see, traditional robots are kept away from humans and they have dedicated tasks, but the NEXTAGE is actually designed to work with humans and they can multitask, and it can also move into different places, whereas the traditional robots are stationary. So these are some of the basic differences, and this one is the NEXTAGE R&D platform. So this is actually an open source robot operating system, which can be used by anyone just to experiment and improve the technologies. So we've actually, we have a lot of customers at UK and Switzerland who are actually using this currently. So this is actually open source, so anybody can actually have access to this. Very interesting for anyone who wants to actually work on robots. So come the year 2013, the Kawada Robotics Corporation was established. So basically we decided to spin it off from the Kawada Technologies group. And as you can see, this actually received the Good Design Gold Award in the year 2013. And we have a production capacity of production. The units have crossed more than 500. And these are some of our customers, Shiseido and Kao cosmetic companies, then obviously Panasonic, Hitachi. So towards the end of this presentation, I'll also show you a couple of more videos. One is a candid video from our robotics office by one of our robotics engineer. And another video which actually shows the actual functioning of the NEXTAGE in a factory. So the factory is actually called the Glory Limited Factory in Saitama. It's a company which actually manufactures different types of machines, vending machines and cash management machines and things like that. And the unique fact about this is that the factory was actually visited by the current Prime Minister of Japan, Mr. Abe Shinzo. He actually visited and saw robots and was really impressed with the kind of features the robot had and the kind of tasks it would undertake. So you can have a look at that video also. So as you can see, Kawada's history speaks for itself. We definitely have the capability and the expertise to come up with any type of robots. So that's it from our side. Thank you for your time. And these are web links and contacts. You can always reach out to us if you have any types of questions or any type of doubts. So thank you once again for tuning in. So after this, we will be having a Q&A session.
Hello everyone, my name is 𝗡𝗘𝗫𝗀. I'm an engineer at Kawada Robotics. My job is system integrator and field engineering. I teach robots how to operate, provide support to customers, and hold workshops to teach customers how to use robots. When I was a student, I studied a quadrupedal robot that use hydraulics. At this time, I want to be involved in robotics work that could help people. That's when I came across NEXTAGE. This robot is NEXTAGE. It is a humanoid robot with 2 arms. NEXTAGE was developed based on the concept of a humanoid robot that works together with humans. This robot includes a 2 arms manipulator, vision, and controller all in one. From now, we would like to introduce the function of NEXTAGE while watching its operation. The hand is replaceable and can be changed to the most suitable end effector depending on the work content. It has 4 cameras, 2 on the head and 2 on the hand. These cameras can recognize the workpiece and detect its position, inclination, and side. The positioning accuracy of the hand is the same as that of industrial robots, and it is good at small tasks such as screw tightening. NEXTAGE doesn't just separate movements for each hand, but also can handle large objects with both hands. NEXTAGE is mainly used in Japan at the moment. However, in the future, we hope that NEXTAGE would be used around you as well. That's all. If you need more information about Kawada Robotics or NEXTAGE, you can check our website. And for any questions, please don't hesitate to contact us. Our staff is more than willing to assist you. Thank you.
So let's start the Q&A, and so we've got a few questions from the social media pages of Techfest, and I'll take them one by one in no particular order. So the first question says, a survey by McKinsey suggests over 800 million workers will see their jobs taken over by robots by 2030. So will intelligent robots replace human in all difficult and cumbersome jobs and professions as part of the progress of civilizations? So you see, so this is a question which is very highly debated, and we get this a lot, especially if you're in the robotics business. So at Kawada, the whole intention of building robots is to free people from cumbersome and redundant jobs. So basically, our vision is basically once we free these people, people will have more time to spend on more creative and interesting jobs. So that is one of our main visions at Kawada for the NEXTAGE robot. But you see, today, robots and automation are coming in really fast. So we need to always upgrade our skill sets and be in sync with the changing times. So just to give you an example, if you look at the 1800s when the locomotive engines were discovered, we see that there was a huge rise in locomotive engineers. But then in the 1900s, when the automobile industry came in and the automobiles were discovered, invented, we see that most of these locomotive engineers started losing their jobs, and we saw a huge rise in automobile engineers and automobile mechanics. So just to compare, most of these jobs can become obsolete if you don't keep up with the changing times. So I'd just like to quote Charles Darwin here, which he said, which is not the strongest or the most intelligent of the species that will survive, but the one that is most adaptable to change. So I think it's very important that we always upgrade our skill sets and we always stay in sync with the changing times. So moving on to the next question. What are the technological advancements in recent years which you would attribute to the development of robotics and AI? So we see that there's been a lot of new technological advancements in the field of AI, big data and machine learning. But if you specifically ask Kawada Robotics, our main feature was image recognition. So if you look at the robots today, the eyes of the robots are very close to human eyes, which actually helps do the tasks more efficiently. So that is one of the biggest feature for Kawada Robotics in recent times. Moving on to the next question. What are the important cognitive, social, and affective issues that impact human interaction with robots in the workplace? So the first thing that comes to my mind is if you have robots in the workplace instead of humans, is how do you build a camaraderie? It's very difficult to build trust and relationships with the robot, right? Because the robot may not show emotions, it may not have the EQ and the intelligence as a human being. So that is the first thing that comes to my mind, and so it's very difficult to build a camaraderie. The second thing is obviously you might become socially awkward because you're interacting with a robot the whole day. You do not have any face-to-face interaction with humans. You might lose your social skills like networking skills and other social skills, so you can become socially awkward. So these two are probably some of the two things I feel can be affected. Moving on. Can the development of artificial intelligence and robotics escape human control, and will artificial intelligence in the future reach a state of self-perfecting intelligence? So this is actually a tricky one. So for this, we actually need to understand the different phases of intelligence. This is how I would explain it. Intelligence is made up of IQ, then we have EQ, then we have AQ, we also have SQ. SQ has been adopted by a lot of companies today like Nike and Ford. SQ is basically spiritual quotient. They say it's very important in today's business world because the whole concept is building a foundation of trust and happiness is now considered important for organizational as well as individual success. So that's one of the factors. But yeah, IQ is intelligent quotient. I think it can be incorporated into robots. But then we have EQ. Can actually emotions of a human being be replicated in a robot? There are a few robots which can actually do some emotions, but we're still not there as yet. And then we have AQ, which is adversity quotient or adaptability quotient, which is actually very important in a human being. They say if you've not gone through a tough time in your life, you fail to develop the adversity quotient in your brain. So just to give you an example, if you're faced with a tough situation and if you don't have an adversity quotient, you don't know how to improvise in that particular situation. And if you look at robots, they're just programmed to do a particular task. So we're not sure whether they can actually, change and adapt into that particular situation. So these are some of the things which are very debatable. So we don't see this happening at least in the next 20 years. Moving on. Can robots be self-aware and conscious like humans? So the conscience itself is such a complicated subject for humans itself. We itself are not very conscious of ourselves at times. So it's highly impossible or very difficult at the moment for robots to be conscious of themselves. And even if they are conscious, how will we be aware of it? So. But there are a few technologies which are coming in called artificial conscious, but that is very highly debatable at the moment, so we're still not sure of how things will move forward. The next question is, how do we prevent humans and robots from being in conflict? A plausible Blade Runner reference. Technology can provide leverage, but how do we ensure that we use technology and don't let technology use us? So at Kawada, our belief is that technologies can always have benefits to humans. There is always this misconception that robots are harmful and they will take over humans and things like that. But and so we tend to be scared of things. and we don't know that we don't know very much. So if we deepen our understanding and understanding of technology, I think it can always be beneficial to humans if we use it wisely. So yeah, so that's what that is just our personal opinion. So we have time. We'll just take one more question, and this one is: how can someone from India take up robotics as a career in Japan? So this one is a very appropriate question. I can just give you my example. So my whole, if you look at my life, how it turned out from, I believe that the easiest way to get a career in Japan or in any other country would be to study in that country. So that's what I did. So I took up post-graduation in Japan from this very unique university called Globus University. So I did my MBA there, and that's where I actually met the people of Kawada, and that's how I actually got an internship and a job at Kawada. So that would be the easiest way. So if you do any kind of course in that particular country, it would help you to get a job in that particular country. And there are some other points. So the government of Japan itself has opened up a lot of the visa rules. They have relaxed most of the visa rules, and they are welcoming more and more foreign workers into the country because we see a labor crunch in Japan. So they want more and more people to come into their country. And the PR rules are much better now. You can get a PR in Japan in 3 years' time. So I would also recommend you to study some Japanese, because your opportunities will be better if you know Japanese language also. And it will also help you deep dive into the Japanese culture. If you can speak the local language, the culture is something which is very highly regarded in Japan. So it's always better to know the culture. I was a bit fortunate because my dad always had collaborations with the Japanese, and I picked up a lot of soft skills from him, and he's been a big influence in how I got into Japan. So it's better, yeah. So like I said, if you know the Japanese culture a bit, the language, and these can help you in easily securing a career in Japan. So and most of the companies are very open. They are, like I said, the government has opened up the rules, and most of the companies are welcoming a lot of people into Japan. So yeah, it's a good opportunity at the moment. So that's it. I think we're done with the Q&A sessions. I hope it was interesting for everyone who joined in today. I want to thank everyone for logging in today, and like to close off the session. So thank you for your time, and please take care. And